students. So my name is Dr. XP Jani. I am working as a professor in Mechanical Engineering Department at Mlritm Reddy Institute of Technology and Management. Today I am going to teach about the theory of machine subject. So it consists of two different topics, that is kinematics as well as dynamics. So in that kinematic subject, we are going to see about the simple mechanisms and velocity acceleration analysis, cam profile, cam and follower profile, as well as gear and gear trains, and straight line mechanism, as well as a correlation component for the slider crank mechanism. These all things we are going to see in the first chapter and second chapter. And third, fourth, fifth, it is related to the dynamics topics and their gyroscope and brakes, governors. This all will comes under the dynamic subject, and vibrations also. So coming to our course objective, our course objective, applying the first course objective is related to the CO1. That means first unit, that is applying the basic components of mechanism analysis, the assembly with the respect to the displacement, velocity and acceleration at any point of the link of the mechanism. And second course objective is respected to the second unit. So that is applying the basic concept of tooth gearing and kinematics of gear trains. So this is related to the second unit objective. And third unit objective is analysis the force motion relationship in components subjected to external force and analyzing of standard mechanism. And fourth course objective is related to the impact, the knowledge of various governors, brakes and operation of the dynamometer. And fifth course objective is related to the model 5, that is analysis the undesirable effect of unbalance resulting from prescribed motion in mechanism and the effect of dynamics of undesirable vibration. So as we said earlierly, total 5 model is there in this topic, that is theory of machine. The first two models are related to the kinematics and 3 models are related to the dynamics. Okay, so coming to the course outcome of this subject, first one is applying the first model, applying the basic component of mechanism, analyze the assembly with the respect to the displacement, velocity and acceleration at any point of link of a mechanism. That is comes under the BL level 3. And second course outcome is apply the basic concept of tooth gearing and kinematic gear trains. That is comes under BL level 3. And analyze the force motion. Third course outcome is analysis the force motion relationship in components subject to the external force and analysis of standard mechanism. That's fall on BL level 4. And fourth course outcome is illustrate the various governor, brakes and operation of dynamometer. That is comes under BL level 4. And last course outcome is that is related to the model 5, that is analyze the undesirable effect of unbalance resulting from prescribed motion in mechanism and the effect of dynamics undesirable vibration. So first two, it is related to our kinematics. There we are going to cover almost all kinematics related topics, and here we are going to learn about the dynamics related topics. So coming to the unit 1 syllabus or model 1 syllabus, first one is the mechanism. So what are the terminology we are going to use in the mechanism, and the Kruger criterion and Kirchhoff law, kinematics inversion of our 4-bar chain, slider crank chain, double slider crank, and kinematics analysis of simple mechanism. That is comes under the velocity and acceleration. In our syllabus we are going to teach only graphical method, not in the analytical method, and mechanical advantage, correlation component of acceleration, Davis steering gear mechanism, Ackerman steering gear mechanism, and classification of cam and follower. So almost 3 different topics we are going to cover in this model. In that main is simple mechanism, because from the simple mechanism is only the total entire theory of mechanism or kinematics of machinery topic will be start. And second model is about the gear and gear trains. So gear and gear trains, first friction wheels and to the gears, types and law of gearing, condition for constant velocity ratio, transmission of the motion, velocity of sliding from teeth, method of interference, condition for maximum number of teeth to avoid interference, expression for arc of contact and path of contact. So here we will see about the derivations as well as problem solving based on the number of teeth in the pinion and the wheel, and gear trains. Next in that model, next last topic is the gear trains. They are simple gear trains, common gear trains, riveted and planetary gear trains, sun and planet gear trains. So there we are going to solve by using only tabular method in the problem. Coming to the third unit or third model, gyroscope. So gyroscope, four-wheeler, two-wheeler, as well as aeroplane, and ship, naval ship. The four different topics we are going to cover in the gyroscope, and static analysis as well as dynamic force analysis. These two force analysis topic also we are going to cover in the model 3. And model 4, governors. It is very important topic in the theory of motion, and as well as brakes and dynamometer. So governors we are going to cover in the almost all types of governors, that is watt governor, Portal governor, Powell governor, and Hartnell governor, as well as sensitive governors also. And brakes and dynamometer, types of brakes, simple block brake and internal expanding brake, and the effect of braking of the vehicle, and dynamometers, absorption type and transmission type. So these are we are going to cover in the unit 4 or model 4. And model 5, total it is depending on the vibrations. Total this unit is exclusive for the only for vibration. So there we are going to cover in the static and dynamic balancing, as well as torsional vibration. That means the main what is the vibrations, torsional vibration, force vibration, and harmonic vibration, and vibration isolation. These all important topics are, and as well as damped and undamped vibrations also we are going to solve in this, or we are going to study in this model 5. So now we are going to enter in the unit. So these are all the textbooks, so that we can, I will share in the description. So this reference and the textbooks we can refer. This is our usual web links. You can see that one. And now we are going to enter in the theory of motion subject and model 1. So this theory of motion, before starting, I want to give the brief introduction about the theory of motion, as well as what are the classification is there in the theory of motion subject. So this theory of motion subject, or this theory of motion topic, it is divided into the main important two different topics. That is, one is dynamics and another one is kinematics. So this dynamics, again it is divided into the kinematics and statistics. So what is kinematics, or what is theory of motion, and what is kinematics, and what is dynamics? This definition will be seen in the next slide. So first one is, what is theory of motion? The subject theory of motion may be defined as the branch of engineering science which deals with the study of relative motion between various parts of the machine and force which act on them. This is called as theory of motion. This is called as theory of motion. This is a definition of theory of motion. So whatever machine or whatever mechanisms is there for our present life, in that what are the motions, that means relative motion, and what are the forces acting on that particular mechanism or particular machine, that all analysis and all kind of studies we are going to see in the theory of motion. And another one important thing is the machine. What is machine? What is machine? So theory of machine definition this is, and we should know about what is machine. The machine reserve energy in some available form and use it into the some particular type of work. So for example, you can take our mixie, grinder, these all things day-to-day application we are using. So there it is taking electrical energy and it is converted into the mechanical energy, and we are getting some useful work from them. So you can take our fan. So that is only machine definition. So it will take some energy and it will give some useful work. That is called as the machine. So this theory of machine, again, it is already we discussed, it is divided into two different category. One is kinematics and another one is dynamics. So what is kinematics? This kinematics definition, one thing we have to keep it in our mind very clearly. We have to study about relative motion between the various parts of the machine without considering the force and mass. That is important. So each and every machines or mechanism having number of links or number of components. In that, only we are going to use to find out the only motions, not their forces. Okay, without considering that force, we are going to study about the relative motion between the various part of the machines. And second one is dynamics. It is quite opposite of the kinematics. So here we are going to see about forces and their effect. Forces and their effect. That is very important. There, without force and mass, we are calculating. Here we are using. Here we are using with the force and their effect. We are calculating, or we are dealing with the mechanisms. So while acting upon the machine parts of the motion, and it is again this dynamic is divided into the two different category, that is kinetics and statistics. So what is kinetics? The theory of machines which deals with the inertia force which arises from the combined effect of the mass and motion of the machine part. So kinetics, it is mainly dealing about the inertia forces. Here what we said, forces and their effect. So kinetics, it is particularly for talking about only inertia forces. And next one is the statics. So here it is deal with the forces and their effect while the machine part or rest. That is important. So this condition only we have studied first year engineering mechanics subject. So almost all the with the rest or constant movement body, if you are affecting external force, what are the things will be happen, how it will be react, how the equilibrium will be there, that we studied in the engineering mechanics subject. So this is falls in that one only. So their effect while the machine parts are at rest. And here we didn't calculate the mass, or we didn't use the mass in the calculation. Okay, so these are the basic introduction about the theory of machine. So theory once again I am recollecting. So theory of machine is divided into the two different category. One is kinematics, another one is dynamics. Then again this dynamics, again it is classified into the two different category. One is kinetics and another one is statistics. So theory of machine, already we see the what is the definition, and dynamics and kinematics. So kinematics without mass and their effect, or force acting on their effect, and dynamics with the force and their effect we are calculating. And kinetics and statistics, the kinetics we have to calculate, we have to use only inertia force, and statistics if we will calculate their force and effect, but the body should be in the rest condition. So this is the basic introduction about the theory of machine. And now we will start the what is machine and what is mechanism. So theory of machine, we are going to study about the how one machine will be forming. From that machine, how we are going to get the output. So output is nothing but our work, what we are going to get, that means the application. For example, if you are taking the same mixer or grinder or fan, the fan means we will get the final output is our, we will get the airflow. And mixer or grinding, already we will get the final grind the floor or grind the any other components. We will any components is like any food items or any juice item, we will grind from the grinder or mixing. So that is the outcome. But for making that machine, we are having number of mechanism. So for example, grinder, if you are taking nowadays, the tabletop grinder is before that another one big types of grinder will be there. There, how the mechanism will be acting on the machine. So there some linkage will be there, like for making that mechanism, some motor will be there. From the motor, the one belt will be there. That belt will be connected with some big stone big stone vessel. Then it will be rotate. Based on the rotation, we will get the outcome. So this all joined together only one mechanism. In that mechanism, we are getting the one machine. So there is a difference between the mechanism as well as machine. Machine is nothing but finally should come some useful work. Mechanism is nothing but by the help of some linkage it will can able to make some motion. That's all. Mechanism should, there is no need of give any compulsory any useful work or not like that, but machine should be give some compulsory some useful work. That is called as machine. This is called as the mechanism. So now you can see the can crusher, and you can see the another one mechanism like a lift like jockey. Okay, so these tools are like a mechanisms, not a machine. Okay, so you can see the mechanism definition. It is a combination of rigid bodies which are formed and connected together by some means so that they are moved to perform some function, such as a crane, connecting rod mechanism in the IC engine. See that one, some function it will perform some function. Already I said it can mechanism mean it can able to make some motion, but it will be give some useful work or not, that is secondary. But it can able to some motion mean that is called as a mechanism. But machine definition we will see. So now this is, you can see that on engine it is comes under category of machine. So that machine definition, the machine receive the energy in some form, available form, and use it into some particular type of work. This is the definition of machine. So there is a huge difference between machine and mechanism. And difference between the machine and mechanism, the similarity between the machine and mechanism, that they are both combination of rigid body. I hope you know about what is rigid body. And next point is the relative motion among the rigid bodies are defined, and the difference between the machine and mechanism, in that machine transform energy to do work, while mechanism do not necessarily perform any function. That is only I said initially. It don't want to give any useful for work to it, but it can able to make some motion. That is sufficient for the mechanism. But machine is not like that. It should give some useful work, because it is, we are giving the energy, so it have to convert into that some useful work. Next, this question you have to, and you have to remember, all the machines are mechanism, but all mechanisms are not machines. Okay, this is one important quotation. All machines are mechanism, but all mechanisms are not machines. Next, there is another one big concept, structure. Okay, so structure, there is a huge difference between again structure and machine or mechanism also. So structure, it is, you can see this diagram, one railway track or any house construction or any bridge construction time, they will make some structure. So that structure, it can't able to move from one place to another place. It will be stay like a rigid body. It will be there in that place only. That kind of things, it can't able to make any motion relatively. So that comes under the structure, but it can able to what is called split the force in equally to the all the places. So train track, you can see that example. It is an assemblage of number of resist bodies, okay, or known members having no relative motion between them. Already I said there is no relative motion will happen in the structure for carrying loads having straining action. The railway bridges, root stresses, machine frames are example for the structure. Okay, next, this is already, this is one type of machine, that is our grinder or mixie. And there is a difference between machine and structure. The first one, the part of the machine move relative to the another, where the members of structure do not move relative. So already we discussed about this point. The machine transfer available energy into the useful for, where the structure no energy is transferred into useful work. And third one is the link of the machine may transmit both power and motion. While the members of the structure transmits force but no motion. Okay, it will be transmit the force, because if you are taking normal construction, civil construction, there is a pillar and column construction. So their column purpose, if you are applying the load in the one particular place, it will be transmit the force to entire body. like a UDL, uniform distributed. It will be distributed the load in the uniformly. That's why it is called as the structure. It can't be able to make any motion. That is very important here. It can't be able to make any motion. That is the first point, I think so. Oh, sorry. Yeah, no motion. Third point. Okay, so this is the difference between structure and mechanism. So our subject, we are going to study about only kinematics related things, not about the structure or not about any machines. Okay, now we are going to study about the how to make the mechanisms. Okay, we are going to study about the only how to make the mechanism. That is comes under the kinematics topic. So here we are going to deal with this concept only. See that one. It will deal with the study of motion subject without considering the force. So you can see one object is there. That object we are going to push. During push, here what will happen? Compulsory friction will be there, and this body friction compulsory here friction force will be affect. Again the body weight will be affect here, W. Again the reaction force will be there. Okay, these all forces will be there when you are moving body from one place to another place. But here we are not going to consider this all related forces. Only we are going to consider when the object is moving, we are going to consider how the velocity will be transformed, how much amount of acceleration it is happening, and how much amount of distance it has to be moved. These three topics only we are going to consider in the kinematics of machinery subject. That is also fall in the first model. Okay, so once again I am explaining. See, that object, if I want to move from one place to another place, we have to consider what are the forces is acting on this body. So this is applied load. Okay, so during applied load time, this body will be get internal load condition, that is the W we can take. And while internal time, compulsory what will be there? Reaction force will be there based on this surface contact. So compulsory opposite side friction force will be there. Okay, so this all forces will be there for the obstacle for this object to while moving. But in this subject we are not going to study this all related forces. We are going to study about only velocity, acceleration, and distance travel. While moving time, how much amount of velocity is there for that object, and how much amount of acceleration happen, and how much amount of distance he has to travel that particular time. These all three motion related things only we are going to study in this module. That is only called as the kinematics. Okay, kinematics definition already I have said. Only we are going to consider only motion without their force and effect. Okay, so now basic terminology we are going to see. If I want to make one mechanism, what are the things should be there? Okay, what are the components or what are the elements should be there to make the mechanism? Okay, that is comes under the basic terminology. So I want to make the machine. For that machine, it consists of mechanism, and that mechanism, if you are taking one machine, it is having number of mechanism. In that mechanism, any one mechanism if you are taking, in that mechanism, it consists of kinematic chain, and it consists of kinematic pair, and it consists of kinematic links. Okay, these three are very important. Okay, these three, if it is there, then we can able to make the mechanism. So number of mechanism or one or two mechanism joined together, we can able to make the machine. Okay, so we can see the definition of these all elements. First one, kinematic links. It is a part of machine which transmits relative motion from one link to the next adjacent link. Okay, so if you are taking, it is linking. Link is nothing but like a one rigid body. Already we have seen what already we have discussed. Mechanism is made up of number of rigid bodies only. Rigid body is nothing but one, like we can consider as a one rod or something like that. Okay, in that rod, if I am giving any motion, this it should be make the motion to the connected another one. It should be transmit the motion to from this link to this link. If you are using here any stone or something like the big weight object, we can't able to make the motion for that. So that is why it is only rigid body condition, and it should be make the relative motion from one link to another adjacent link. That's why we are using. If you are using any stone or something like that, or big rock, then we can't able to possible. That's why given the condition, relative motion from one link to next adjacent link. Next, what is kinematic pair? So two kinematic links or elements are connected together and transmit a constrained relative motion, then the pair can be called as a kinematic pair. Okay, here we are seeing one new terminology, that is constrained relative motion. So what is constrained means, we will see in the coming slide. So we have to remember this word now, constrained relative motion. So first one is, it should be transmit the relative motion from one link to next adjacent link. And second one is kinematic pair. The definition is when two kinematic links, here kinematic link is very important. So kinematic links are elements that are connected together to transmit a constrained relative motion, then the pair can be called as kinematic pair. After joining of two links, it can able to make the motion, then only it is called as a kinematic pair. And third one is kinematic chain. So kinematic chain, there is a one good definition is there, that is the number of links connected together. If first link connected to the last link, to transmit the relative motion, then the chain formed can be called as kinematic chain. Sir, what is here connected to the last link to transmit the relative motion? For that, you can see this example. Here, this is link 1, link 2, link 3, and link 4. You can see now, first link is connected with the last link. That is only they mentioned here. The last link to transmit the first link connected to the last link. This is the first link. The first link and fourth link is connected with each other. If it is there like that, then only it can able to transmit the motion. That means relative motion. So relative motion is nothing but, if I am giving some motion or some movement to this particular link, okay, it can able to make some motion like that. Maybe the clockwise rotation, other maybe it can able to make some acceleration like that. Some kind of motion it can able to make. Okay, this link. But the same time, I am connecting another one link with this particular link. It is like this. Maybe I'm assuming like that. Say by using this kind of rotation, it can able to also make some movement, some relative movement. It should be related to this one. Then only we can able to call it as a kinematic change. Suppose I am giving the motion like that, but this is movement is like this, or some other place it is doing like that. That means what I am expecting, that kind of motion, if it is not come, then it is not called as a kinematic chain. Okay. I hope you understood that what is kinematic chain. So next mechanism, simple definition, a kinematic chain. In the kinematic chain, if any one link is fixed, then the chain is called as mechanism. You can take, this is a reciprocating engine mechanism. Okay, normal piston, crank, slider, cutting rod arrangement. Okay, piston is moving. And this is a fixed to one point, or like here maybe we are giving the input to this crank, and this is your cutting rod. Okay, so during this movement, what will happen here? This first link is fixed. That is important. This first link is fixed one. Then only it can able to make the mechanism. Compulsory one link should be fixed one, should be there. So this is for just for understanding purpose. The diagram is like that. Coming to the application point of view, how this will be, that we can see in the coming slides. Then you can able to understand how we can fix the link in the real-time application. Okay. So next, it is a machine. So already we know what is machine. Already we see about the machine definition also. The machine receives energy in some available form and use it in some particular type of work. So these are all the basic terminology about the mechanism or machine. Okay. So first one is the kinematic link, kinematic pair, kinematic chain and mechanism and machine. So kinematic link is nothing but one small rod or something, you can assume it. If two like that kinematic links will be joined together and make the constraint relative motion, and it can able to form as a kinematic pair and kinematic chain. So number of link connected together, the first link connected with the link to the transmit the motion, first link is connected to the last link, first link is connected to the last link, then it is called as the kinematic chain. And mechanism, if any one of the link is fixed one, this is a fixed link, if it is fixed one, then it can be called as a mechanism. And already we know about what is machine. So you can see the same example now. So one is the fixed link, this is the slider, this is a slider, and this is a crank, this is cutting rod. Okay, so this is the basic terminology using for the basic diagram of reciprocating engine part. Now coming to the real-time application. This is our real-time application. This is the view of cylinder piston arrangement. So here crank. Okay, this is a crank because it will be rotate 360 degree. Okay, and this crank is connected with the cutting rod, and cutting rod is connected with the piston. This piston is moving in the inside the object like this. This slider motion will happen here. Okay, now what is this fixed link? What is this fixed link? This fixed link is nothing but this entire shell is this cylindrical arrangement is comes under the first link. That means the cylinder arrangement is comes under the link 1. Okay, so if you are considering link 1, the inside the link only first link is there as well as last link also there. So that is only definition of mechanism. The kinematic chain, any one of the link is fixed, then the kinematic, then the chain can be called as the mechanism. So like that, any one here, the fixed link, this is a cylinder is like a fixed link, it is acting as a fixed link, then it can able to make as the motion. This is called as the mechanism, and this entire setup is called as a machine. Okay, so next classification of links. Already I said first starting kinematic link, like that I said. So everyone having doubt about what is kinematic link. That time I said just you can think of like a one rod, that is you can assume as a link I said. Then here now we are going to see what are the things we can call as the links. Okay, the classification. There are 3 different types of kinematic links. One is rigid link, another one is flexible link, and third one is fluid link. So in the rigid link you can see the rigid is one which does not undergo any deformation while transmitting the motion. Like that is like a rigid link, like a rod. We can assume as a one rod. So rigid link does not exist, and if the deformation of the link negligible, then it can able to consider as a rigid link. So it should not be deformed during the motion transmission. Okay, next flexible link. So flexible link, the kinematic link can be called flexible link when the transmit relative motion by undergoing deformation without affecting the motion transmission. So it can able to make the deformation, but during the motion it should not affect the transmission. Then it is called as the flexible link. So for example, belt and rope drive. So belt drive it is there. It can able to transmit the motion from one pulley to another pulley, but during one pulley to another pulley, that time it can able to make some deformation, but it will be not affect to the transmission of the motion. Correct. Same like that cycle chain. It can able to transmit the motion from shacket to front shacket to here pedal shacket to wheel shacket, but it will not affect the transmission of the motion. Okay, so this is the example of the flexible link. And third one is the fluid link. So how the fluid will be act as the link? So the relative motion transmitted to the fluid, the form of pressure or compression, then the fluid can be considered as the fluid link. What is my point? So there hydraulic press, jack, screw jack, okay, brake, normal brake, if you are using the four wheeler or any buses or any big trucks, okay, there we are, whatever we are using the brake, that is comes under the, what is that, hydraulics only, hydraulic process, hydraulic only. And somewhere we are using the pneumatic also as a link fluid. So this is the example. You can see the brake. People are having doubt how it will be active. See, this is one example. You can see that example. We are applying the low pedaling we are doing. Okay, pedal we are pressing automatically from here. Okay, you can see from the cylinder, the pressure is applying to the brake pedal, and it is stopping the vehicle. It is stopping the vehicle. The same like that, we can see the screw jack. Inside the screw jack, oil will be there. That is also there, act as the one. Again, vehicle, if you are going to any vehicle wash station, there also ramp will be there. There hydraulic jack, big hydraulic jack will be there. By the hydraulic power only, the people are washing the vehicle. We can able to lift the vehicle there. In their vehicle, by using the hydraulic power, we are lifting. So that fluid also acts as the link, kinematic link. Okay, thank you. We will see in the next remaining all topics. We will see in the next coming classes. Thank you.